Hello friends and welcome to YouTube channel freedomtech, and in this session what we are going to learn? In this session we are going to control this 3D printed robotic hand with the help of cvzone hand tracking module. So let me first show you a demo. So as you can see, it's detected my hand, 5 fingers. So if I make action like this way, okay, open, okay, if I make thumb down, thumb up, okay, this one, as you can see, down, open. So as I mentioned, I will share you the code and how basically the cvzone work for this hand, this 3D printed hand. So we are going to see all these things step by step. But before we move to our practical, friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, let's get started. So friends, as you can see, this is what our 3D printed hand. We have basically here 2 SG90 servo motor and 4 MG995 servo motors. So we are going to control 2 SG90 servo motor. One is basically upside down, as you can see. This is the upside down motor, servo motor SG90, and this is also for thumb. So these two servo motor, this 2 SG90 servo motor is basically for controlling the thumb action, and we have here 4 MG995 servo motors which basically control our 4 other fingers. Okay, so basically we are going to control 6 servo motors, okay, with the help of PCA9685 servo motor driver board. So friends, first what we want here, we want a Raspbian Buster legacy version which is 32-bit version. So you need to first install Raspbian Buster legacy version on Raspberry Pi 4, okay, because mediapipe is not work with Raspbian OS Bullseye 64-bit version. So we need here Raspbian Buster legacy version, okay. So I have installed a Raspbian Buster legacy 32-bit version on Raspberry Pi 4. Then we need here opencv, tensorflow-lite, mediapipe and cvzone. So I have already created a video how to install opencv, then tensorflow-lite on Raspbian Buster legacy version. But I have created the video, in that time we have older version of opencv. So right now we have latest version which is 4.60. So what we want here, I just want to show you here, just note. So this is the repository for installing opencv on Raspbian Buster, Raspbian legacy, okay. So if I open my file manager, as you can see here, I have here a Raspbian legacy repository which I have cloned, okay. So you need to simply make some changes. So if I open this folder, this is what the install.sh for installing opencv. Okay, so simply we need to open our terminal. Okay, if I run ls command here, this is what our repository, Raspbian legacy. Simply run the cd command because we need to go inside our repository. So cd Raspbian legacy ls, and we have here install.sh, and this is for installing TensorFlow-Lite on our Raspbian Buster. So you need to give first full permission for these two bash script. So run the command chmod 775 and install.sh and tensorflow-lite.sh, just hit enter. Then you will see the color basically change. It's now a green because we changed the permission, okay. So now simply run the command bash install.sh and just hit enter. It will install opencv latest version which is 4.6.0, which I have already installed. That's it. So we have done with installing opencv. So now we have a latest version of opencv on our Raspbian Buster. Now we are going to install tensorflow-lite sh. So same way, run the command like this way, bash, and mention the script name which is the tensorflow-lite.sh. just hit enter. It will basically clone examples folder. As you can see, we have here examples folder, okay. So now we have done with the script, the bash script. Now we need to move inside the examples folder. So what I am going to do, I am going to just go back. Okay, again simply file manager, we need to go inside Raspbian legacy folder, then we have here examples folder, then light folder, then again examples, then here we are going to search for object detection folder. As you can see, object detection folder, and inside that we have Raspberry Pi folder. As you can see, if I open the file manager full screen way, so this is the destination. Okay, right now we are inside /home/pi Raspbian legacy examples light, examples, object detection, and Raspberry Pi. Okay, so inside the Raspberry Pi we have here requirements.txt file, which basically install TensorFlow-lite. So this is the requirement for installing TensorFlow-lite. So right click and open with text editor. Okay, so by default, when you download the examples folder, by default you will see here something like 4.5 something version, because when I have created this repository, in that time we have older version of opencv, but right now we have latest version which is 4.60. so you need to simply delete the old version and mention here like this way, 4.6.0. as you can see, I have changed the version 4.6.0. that's it. So this is the basic change you need to mention inside requirements.txt for installing TensorFlow-lite. Okay, as you can see, I have mentioned the changes. So now we need to run our bash script. So this is the script, bash script. As you can see, setup.sh. So for that we need to go inside this folder. So open the terminal, just open terminal, and right now I am inside Raspbian legacy folder. So now we need to go inside Raspberry Pi folder, which we have inside examples folder. So we need to mention all these folders names. So cd examples, cd space examples, then light folder. So mention light, then slash again, then we have again examples folder. As you can see, examples folder. So we need to mention here examples folder. Then we have object detection folder. Just mention obj and press tab, it will auto complete the folder name. Then we have Raspberry Pi folder. So mention RASP. Okay, RASP, press just tab button, auto complete the folder name, and just hit enter. Now here we need to run our setup.sh file for installing TensorFlow-lite. So run the command bash and setup.sh, just hit enter. It will install TensorFlow-lite on our Raspbian Buster legacy version. So this is how you will have latest opencv and TensorFlow-lite for Raspbian Buster legacy version. So we have done. Now we need our mediapipe and opencv. So let me run cd command, and I am going to clear all these things. Also I am going to close all these things. So we have only our terminal. So we are done with opencv and TensorFlow-lite. Now we need mediapipe. So right now I am on Raspberry Pi 4. Okay, so just run the command pip3 install mediapipe. Okay, mediapipe hyphen. As I mentioned, I have here Raspberry Pi 4, so I am going to mention RPi 4. Suppose if you have Raspberry Pi 3, you need to mention RPi 3. Then it will install mediapipe on Raspberry Pi 3. Right now I am on RPi 4, so I am going to mention here RPi 4. So mediapipe hyphen RPi 4, just hit enter. It will install mediapipe on our Raspberry Pi 4 Raspbian Buster legacy version. So we have done with mediapipe. Now next package, which is cvzone. So run the command pip3 install cvzone, just hit enter, and it will install cvzone on our Raspbian Buster. So I have already installed cvzone. So this is how you need to install opencv, TensorFlow-lite, then mediapipe and cvzone on our Raspbian Buster. Now we have done with package installation. That's it. Now we are going to move on our hardware side. Okay, so friends, now hardware connectivity. So we have here basically SG90 servo motors, and we have here MG995 servo motor. So we have basically here 4 MG995 servo motors for 4 fingers, and for thumbs we have here 2 SG90 servo motors. So we have basically here 6 servo motors, 2 SG90 servo motors for controlling our thumb, and other 4 fingers we have here MG995 servo motor. So we are going to basically control 6 servo motors with the help of Raspberry Pi 4. For that we need here PCA9685 servo motor driver board. Okay, so as I mentioned, I am going to explain right now how you can connect these servo motors with the help of PCA9685. Okay, so this is what our PCA9685, as you can see, we have basically here V+, VCC, SDA, SCL and the ground. Okay, then other side also we have ground and V+. Okay, because we are going to use here other side. This is the first side. If I mention, this one is the first side and this one is the second side. Okay, so this first side we are going to use here ground pin, then SCL pin, SDA pin, VCC pin. Okay, and for this side we are going to use ground pin and V+ pin. Okay, V+ pin. So how to connect these pins with the Raspberry Pi 4? So I have here Raspberry Pi 4 pins. Okay, so this is what our Raspberry Pi 4 pins, and then we have here PCA9685. So let me, if I make like this way. Okay, so we are going to see first this side. So start with VCC. Okay, so PCA9685 VCC pin, which we want to connect with Raspberry Pi 4 pin number 1, which is 3 volt. Raspberry Pi 4 pin number 1, which is 3 volt. So VCC pin connect with the 3 volt of our Raspberry Pi 4 pin number 1. Okay, then SDA pin, SDA connect with the Raspberry Pi 4 pin number 3, which is SDA GPIO2. As you can see, it's mentioned here GPIO2 SDA pin number 3, a physical pin number 3, and GPIO pin number 2 SDA. So pin number 3 connect with the SDA. Then SCL of PCA9685 board, SCL pin which we want to connect with Raspberry Pi 4 GPIO3 SCL pin number 5. As you can see, it's mentioned over here the SCL. So SCL pin, which is physical pin number 5, GPIO pin number 3, which we want to connect with the PCA9685 board SCL. Okay, and then of course ground connect with the ground pin number 6. Also you can connect with the pin number 14, because pin number 14 is also ground. Okay, so ground connect with the ground, and then SCL connect with the SCL, which is the GPIO3 physical pin number 5. Then SDA connect with the GPIO2 physical pin number 3, which is SDA, and VCC connect with the pin number 1, which is 3 volt. Okay, so this is how you need to connect this first side with the Raspberry Pi 4. Now, okay, the other side of PCA9685, which is ground and V+. This ground and V+ is basically for powering our servo motors. So we need here external power supply for this side. So for external power supply, we need 5 volt external power supply. So I have used here Arduino Uno board for external power supply, because on Arduino Uno board, if I open Arduino board, because on Arduino Uno we have 5 volt. Okay, we have 5 volt, also we have ground. So you need to simply power, as we always power on our Arduino board, simply just connect the wire with the Arduino Uno board. Okay, then you need to simply connect the 5 volt of Arduino Uno to V+ of PCA9685, the other side. This is the second side, as I mentioned. Okay, this is the first side, this is the second side. Okay, so this side ground and V+, which we are going to use as an external power supply for servo motor. So we need to connect Arduino Uno 5 volt, Arduino Uno 5 volt with V+. So just use here jumper cables and connect the 5 volt to V+ of PCA9685, and connect the ground pin with ground of our PCA9685. This is the second side. Okay, so this is how you need to connect the hardware with PCA9685, means you need to connect the wire connection. Okay, so as I mentioned, I'm going to explain again here this side for Raspberry Pi 4. So VCC connect with the Raspberry Pi 4 pin number 1, which is 3 volt. Okay, then we have here SDA. So SDA connect with the SDA. As you can see, it's mentioned here SDA pin number 3, physical pin number 3, GPIO 2. Simple. Then we have on PCA9685 we have SCL pin. So SCL connect with the SCL pin of our Raspberry Pi 4, which is physical pin number 5, GPIO pin number 3. Simple. Then of course PCA9685 ground pin, ground connect with the Raspberry Pi 4 ground. So we have more than one pin ground, so you can connect either with the pin number 6. Of course we have your pin number 14, so you can connect 6 or you can connect 14 for ground. Okay, so this is what our this side, the first side. And as I mentioned, this side we are going to use as an external power supply for our servo motors. So I have here Arduino Uno board, which basically we have on Arduino Uno board we have a 5 volt. So Arduino Uno board 5 volt pin, this is the 5 volt pin which we want to connect with the V plus and ground connect with the ground. Okay, so only this side we are going to only use V plus and ground. We don't use other pins. Okay, on second side we don't use other pins, we only use V plus and the ground for power in our servo motors with the help of Arduino Uno board. Simple. Okay, so I hope you all clear. So now this is how we need to connect our Raspberry Pi 4 with our PCA9685. Also the Arduino Uno as a external power supply we are going to connect this side. Simple. Now how to connect the servo motors with PCA9685. So on PCA9685, as you can see, we have basically 1, because this is the 0, but we are going to count 1. So 0 to 15, so basically we have 16 channels. We have 16 channels, it means we can connect 16 servo motors on our PCA9685 servo motor driver board. Okay, so this is the data pin, this one is the power pin, and this one is the ground pin. So as you can see, the basically yellow color, or we can say orange color, is basically a data pin, and red color is basically a power supply, means power pin of our servo motor, and then this is our ground pin. So if I open servo motors, as you can see, this is what our servo motor, and on servo motors we have basically orange, red and black color wires. So of course we need to connect these pins in format like this way. So orange come here, then red come here, and then black come here. So this is how you need to connect the servo wires. Okay, so orange come here, then red come here, and then black come. For the ground you need to connect here. Okay, so this is how you need to connect the servo motors wire with the PCA9685 board. Simple. So I hope you all clear, and this is how I have connect the hardware. Okay, so I have used here 0, 1, 2, 3. Okay, 0, 1, 2, 3 these channels, and then I have used here 8 and 11 channel. Okay, so basically if I count 1, 2, 3, 4, 5 and 6. So this is how I have connect 6 servo motors with PCA9685 servo motor driver board. So this is for our hardware connectivity. Now we are going to simply move on our code. Okay. So now friends, we need a repository. For today's session, I have created here a new repository, and the repository name is mg995sg90pca9685, because we are going to control all this hardware with the help of Raspberry Pi 4. So this is the repository. I will mention link of repository. You need to simply copy and paste link inside the browser. Then go to the code, copy the link from here, open terminal and run the command git space clone space paste the link of our repository. Just hit enter. It will clone our repository which I have already cloned. So then what we want to do, we need to first enable here I2C interface. So run the command like this way, sudo space raspi hyphen config, sudo space raspi hyphen config, just hit enter. Then come to the third option, which is interface options, just hit enter, and then I2C P5. As you can see, I2C P5, just hit enter. Then would you like to ARM I2C interface to be enabled, just come to the yes and hit enter. Okay, then again enter. Okay, then press tab button, come to the finish. That's it. We have enabled I2C interface. Now we download our repository. So just open file manager. This is what our repository, and this is the text file. Inside that I have mentioned the package which we want here. So open with text editor, and this is the package Adafruit-circuit Python servo kit. This is the package for controlling PCA 9685 board. Okay, this is basically package for PCA 9685. So just copy like this way, just copy. No need to run a sudo. Okay, remember this thing here, no need to run sudo. Okay, so just copy from pip3, okay, and just open terminal and just paste here and just hit enter. Okay, so I have already installed the package, that's why it's a requirement is already satisfied. As I mentioned, there is no need to run this command with sudo. Okay, you can run this command as a normal user. So run the command like this way: pip3 install Adafruit-circuit Python servo kit. This is the package. Just hit enter. That's it. It will install the package. Okay, so which I have already installed. So we have done. Now simply we have here, this is the basic code. Okay, if I open this code with Tony Python ID, as you can see, this is the basic code from Adafruit servo kit import servo kit. This is how we need to call our module servo kit. Then kit is equal to servo kit, our module servo kit, this one servo kit, and channels. Channels is equal to 16. As I mentioned, we have here 16 channels on our PCA 9685 board. Means we have here 16 pins. 16 pins on our servo motor PCA 9685 driver board. So we need to mention that channels number. So 16. Okay. Then while loop, then A is equal to input. Here you can mention the input, the angle. So we have basically angle 0 to 180. You can start from 0 and end with 180. So if I run this code, if you mention 0, the servo will be move at the 0. If you mention 90, servo will be move at the 90 degree. If you mention 180, servo will be move basically 180 angle. So this is the end of the angle 180. If you mention 181, okay, as you can see, angle out of range, because this servo is basically move only 0 to 180. Okay, so this is the basic code. This is the basic code for controlling servo. So I have mentioned this code, and here it is. As you can see, I have mentioned 0. So 0 is basically first channel of our PCA 9685 board. Means if you connect the servo motor at the first pin of PCA 9685, then it will work. Okay, if you want to use the second channel, so second means because on PCA 9685 it start with 0. Okay, so if you go with 0, so this is the first. If you want to connect next one, so you need to mention here 1. Okay, just save it. Again, connect the servo motor with first channel, then you need to mention the angle 0180, and the servo motor of course will move. Okay, so if you want to go with second, so you need to mention here, just change this one with second. If you want to go with 10 number channel of PCA 9685, you need to connect servo motor with 10 number pins and mention here 10, and it will basically you can control basically a 10 number servo motor. Okay, if you want to go at the last, so 15, you can control the 15 number servo motors. Mean you can basically control here PCA 9685 15 number pins. So this is how you need to mention over here pins 0, then of course 5, 8. Okay, whichever pin you want to use, you need to mention that pin over here. Okay, so this is how you can control PCA 9685 servo motor all channels 0 to 15. Then we have our main code, which is the test2.py. This is the main code where we are going to call our cvzone module. Okay, as you can see, from cvzone.hand tracking module import hand detector. Then import cv2 for capturing our video file, a live video frame with the help of our USB web camera. I have used here a USB web camera. Simple. Then from Adafruit, this is the same thing. Okay, for calling our servo kit, same thing as you can see from Adafruit, servo kit, import servo kit. Then cap is equal to cv2 video capture. This is how we call our video camera, a web camera. Then detector is equal to hand detector, detection confidence level, and maximum hands we are going to use here only one hands. Okay, so this is how we need to call our module, our cvzone hand detector module. As you can see, import hand detector, and I have called here detector hand detector. Okay, then kit is equal to servo kit, as we mentioned in our first file. Kit is equal to servo kit, same way kit is equal to servo kit, and channel 16. Then success img cap.read, we are going to call our camera. Then hands and image is basically our detector variable, this one, detector variable. Okay, so detector dot, what we want here, we want here a hands. So detector is variable detector dot find hands, it will find hands, and inside that we need to pass our img, as simple, img, simple. Then it will basically track our hand. Okay, and now we have our hands. Okay, so we can simply create our condition. So if there is hands, hands1 is just a variable, hands1 is equal to hands, from hands we are going to use a first hand, so 0, okay, index 0, so 0. Then we are going to use fingers 1, this is just a variable, fingers 1, and detector, again we are going to call our variable detector dot fingers up, u capital, as you can see, u capital, so fingers up, and inside that we need to pass our this hands 1. Okay, this hands 1. Then it will print a 5 fingers up position. So now I am going to run the code, and then you will get the idea. Okay, so this is what our 3D printed hand. If I show hands to the camera, and inside that shell, as you can see right now, we have 5 ones. It means we have 5 fingers up. Okay, okay, so that's why it says we have basically 5 fingers up. So if I make all fingers down one by one, okay, all fingers inside the shell, as you can see, we have now 50. Also our 3D printed hand is all the way down, all 5 fingers are down. So if I open fingers one by one, as you can see, it's opening all fingers. Okay, so the concept is what, when there is all 5 1, it means we have all fingers up, and if there is 0 0, it means our finger is basically down. So this is the concept. So we are going to start with, this is for thumbs and this is for all other 4 fingers. So this is for thumbs. So this is our 0 1 2 3 and 4. So for that, now we are going to simply create our condition. So if I make like this way, so now what we are going to do, we are going to use here our fingers 1 variable, because this fingers 1 variable is our all fingers data 0 and 1. So from this finger 1 we are going to use a condition, the if condition. So if fingers 1 0 index means this first finger, which is our thumb. So if fingers 1 0, this is the index for fingers, 0 is equal to 0, means our finger is down, the angle is 180. So kit.servo 0, this is the first channel, 0 dot angle is equal to 180. Then elif the fingers 1 is 0 is equal to 1, means if the fingers is up, then we are going to mention kit.servo 0 and angle is 0, angle is 0. Okay, so if the fingers 1, as I mentioned, we have here for thumbs, we have here 2 servo motor. One is basically control the thumb down and up, and another one servo motor is basically control full way thumbs down. Okay, means when we touch our fingers to pinky tip. Okay, so we have here basically 2 servo motor. One is basically only control the thumb finger down and up action, and another servo motor is basically control our thumbs touch to the pinky tip. Okay, so that servo motor is basically upside down. Okay, let me show you here. If I start the camera, then you will get idea. As you can see, if I make thumb down, move like this way. As you can see, thumb is move like this way. Okay. So basically we have here 2 servo motor for thumbs. So for that, this servo motor is basically upside down. So I have mentioned here for this servo motor, I have mentioned a reverse angle. As you can see, when the fingers is 0 is equal to 0, means our thumb tip is basically 0, the angle is 0 for another servo motor. Okay, and if the fingers is 0 is equal to 1, we have 90 angle, because we don't want full way down a servo motor. We don't want here basically full angle 180 range. We only want 90 range. So 0 and 90. Simple. Then our next finger, which is first finger, this is for thumb fingers. Okay, so we have done with thumb fingers. So now if fingers 1 means this one. Okay, so if fingers 1 is equal to 0, we have a second channel. This is the PCA 9685 channels 2 and angle 180. If the fingers 1 is 1, okay, the kit servo 2 angle 0. So same way I have mentioned all other fingers and all other channels of our PCA 9685 board. Okay, so this is how you can control 3D printed hand with the help of cvzone hand tracking module. So now we have done. So now we are going to see a final test. Okay, so this is what our 3D printed hand, and if I show, just a minute, as you can see, thumb down, next finger, next one, next one, next one, all fingers down. Now we are going to open our fingers one by one. Okay, and this one, last one, which is our thumb. So this is how we can basically use a PCA 9685 servo motor driver board for controlling more than 2 servo motors. Okay, we can basically control here a 16 servo motors. Okay, so I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.